Hello everyone and welcome to another lesson. Today I'm going to go over how to write the formula equation, complete ionic equation, and net ionic equation. We are going to be continuing in our chapter 13 notes, and I'm going to be starting on slide 19. So you are going to use what you have previously learned about solubility. So we will still use the solubility chart to identify if something is soluble, meaning aqueous, or insoluble, meaning it will form a solid precipitate. When we get compounds from a chemical equation or a chemical reaction. Now, we will also be doing dissociation as well, and that will only apply to our soluble aqueous compounds, okay? So again, as I said, this unit builds upon itself, so we're going to use things that we have already learned when writing these equations. We will also go back to something else that we've already learned, which is double replacement reactions. So again, there are three types of equations that we are going to be writing. Please note that these are all going to be double replacement reactions. You can assume that for the time being. So here's some review on those double replacement. You might also see double displacement as well. So like switches with like. So that means that the metals will switch with each other. The cations, the positively charged ions, which are usually the metals, the first element or polyatomic ion will switch with each other, okay? Again, you can assume that all of these reactions will be double replacements. So like switches with like, I've always taught you guys, when I previously taught this, to switch the first element or polyatomic ion with each other. Once you get your new compounds, you will have to make sure you do crisscross, okay? And this is where those charges come in handy. So if you go back to your periodic table, make sure that you copy this over from the content library, okay? So in the content library, there's actually two periodic tables that you have. So one is the charges for each of the groups, and then the other is the that backside of your physical copy of the periodic table that has the polyatomic ions on it. So you will have to use both of these as well, in addition to using this chart for solubility. Okay, so we have a lot going on here, but we will break down how we will approach each of those types of questions. So again, crisscross, make sure that you have those charges and you do the crisscross to get your new compound written correctly. And then of course you have to make sure that you balance. For the most part, to make balancing easier, this side of the equation will already be balanced for you. So you just have to worry about balancing your products. This is really similar to chapter 8 where you had to predict products. Okay, and you're only balancing your products. And then you have to identify if something is aqueous, which means it is soluble, or it will form a solid precipitate, which is insoluble. And use that chart that I just showed you and that we just went over previously. Again, if there is any transition metal, I will give you the charge of that. So for this first example here, we are just going to practice the basics, which is writing the products, okay? So like will switch with like. So I'm going to switch the NH4, that is ammonium, that is a positively charged cation. It's also a polyatomic ion. So again, with polyatomic ions, just focus on the thing that is inside of the parentheses. Please, for now, we're going to ignore those subscripts, until we balance. So we are going to switch likes with likes. I'm going to do that down here just to kind of show my work before I write my final answer. So the NH4 is now going to be with the NO3, so two polyatomic ions together. Again, just write the thing that's in parentheses, okay? So those two go together. And the cadmium, the CD, will now be with sulfur. So that's the first step. Just write the things that go together. Now, the second step is to write the charges, okay? So again, with the polyatomic ions, those you will find for the polyatomic ion charges, you will find that on the back of your periodic table. Again, I have the snippet here in your OneNote. So I have NO3, which has a charge of -1. And then I have ammonium, which has a charge of +1. So I'm going to go back here. So this is +1. Here, we'll do that in a different color, just so we can see it. So this is +1 and this is -1. Now, if I do the crisscross for that, again, the crisscross is just a way to more quickly figure out what the right way is to write your new compound. So this 1 becomes the subscript here, and this 1 becomes the subscript here. Now, since we don't have to write the 1. If you'd like to, you can, but you don't have to, okay? I would just write as my final answer, the final compound, NH4, NO3. Now, I know that looks a little crazy because it's two polyatomic ions that are together. If you want, you can write them in their parentheses if you would like, if that just helps, you know, for you to visually see, hey, these are two different things. They do not have any subscripts. Since we did the crisscross, we just had 1s. Now we're going to do the same thing with our other compound. So cadmium, I told you the charge is +2. So that's +2, I would give you that. Sulfur, that's something that you would just find on your periodic table. So you'd find the group that it's in. So sulfur is right here. So it will have a charge of -2. So I'm going to go back to my notes and I'm going to write -2. So with this one, again, we do the crisscross. So this 2 becomes the subscript here. This 2 becomes the subscript here. So if you have something like this, CAD2S2, well, you can simplify that to simply just be CDS, okay? Please make sure that you simplify because otherwise it will throw off how you balance that chemical equation. So the last thing that we have to do is balance. So this side, everything's already balanced for you. So the first thing that I notice is I'm going to start with the NH4. So notice on this side, okay, that we have 2 NH4s, okay? So for this, so again, notice there's a 2 right here. So that means that I'm going to have to put a 2 in the front here in order to balance it, which is good because now I'm saying I have 2 NO3s and I have 2 NO3s on this side. We have 1 sulfur and 1 CD on this side and on this side as well. So I just have to write this 2 in order to balance it. And if you'd like to, you can write a 1 here, but you do not have to do that. So that's the first thing. And again, we have already done this before, so this should look familiar. Then the next thing we have to do is figure out the solubility, okay? So to do that, we have to go to that solubility chart. So again, when figuring out solubility, you're going to look at that anion, the negatively charged ion. So we have NO3 and S. So we're going to start here, okay? So if we go back to that solubility chart, okay, you're gonna look here in this section and we're gonna find NO3. So NO3 is right here. There are no exceptions for it. And this is going to be soluble. So that means that for this subscript, I'm gonna write AQ for aqueous, okay? Again, NO3, if you ever see that in a compound, it is always aqueous. For the next one, we're going to find sulfur, okay? So let's go to the chart. So we're gonna find sulfur, again, in this section. So I found sulfur, and I'm gonna double check to make sure that the CD, because remember, it's CDS that we're looking at. I'm gonna make sure that the element it's with, CD, is not listed as an exception, okay? So NH4, no. It is, CD is a transition metal. It is not in group 1. It is not an alkali metal. So I do not see it listed as a exception. Therefore, this has to be insoluble and will form a solid precipitate. And this is how most of these reactions will go. One thing will be aqueous for the product and one will be solid precipitate that will form. I'll go over a situation though where you will have something where both of them are aqueous, okay? So that is how we approach just writing the products, okay? Again, when these are all double replacement, you can assume that. Like switches with like, so just first start off what goes together, okay? Just write the things that go together, ignore these subscripts for the time being. Then you'll do the crisscross, okay? And these charges you will find on your periodic table, okay? Then you will do your crisscross, write your products correctly for the new compounds. Then you have to go back and balance. Remember, this side will already be balanced for you. And then lastly, you have to figure out if these are aqueous, will form a soluble compound, or are they insoluble and form a solid precipitate. Okay, so we have already done this before. The only thing that's new is the whole, is it soluble or insoluble part of this.